When we picture like extreme survival conditions, our minds usually go straight to the wilderness.
Right, yeah.
We imagine someone trekking across the Sahara Desert or, shivering in a tent at Mount Everest. We rarely look out our own living room windows.
No, we really don't.
But for those of you listening, what if the most punishing climate crucible on Earth is actually the suburban sprawl of central Oklahoma?
I mean, the sheer volatility of the weather in that part of the country creates this remarkably hostile environment for human comfort. We interact with thermostats every day,
Huh.
largely taking them for granted.
Completely.
Yet, creating a stable 70-degree indoor climate when the outside world is swinging wildly between, like, triple-digit heat and freezing ice storms,
Yeah.
that is a massive feat of thermodynamics.
And that is the foundation of our deep dive today. We're looking at a rather unconventional set of sources.
Yeah, it's a really interesting mix.
It's a collection of website materials and an internal customer service AI training document. They call it the Dave AI FAQ. And this all comes from Hartzell's Heat and Air, which is a family-owned HVAC business out of Kingfisher, Oklahoma.
It provides a super unique data set.
Yeah.
I mean, we are looking at public-facing technical guides right alongside the behind-the-scenes operational playbook of a regional contractor.
Exactly. And the mission here is to look past the standard local marketing you might expect from a trades company. We want to uncover the high-stakes science of indoor climate engineering.
Which is way more complex than people think.
So we are going to explore how extreme weather pushes modern mechanical technology to its absolute limits. And for you, the listener, even if you are nowhere near the market for a new air conditioner,
Right, even if you're just sitting on your couch.
you are about to see why the foundational ideas you have about keeping a house comfortable are likely backward.
Because dealing with the kind of weather swings they see in Oklahoma, it requires a complete perspective shift. A standard cooling system engineered for a mild coastal climate. It will physically fail under the atmospheric pressure of the Midwest.
Okay, let's unpack this environment. Central Oklahoma serves as, like, the ultimate HVAC test track. The sources point out that summers regularly hit 100 to 110 degrees Fahrenheit.
Yeah, but temperature is only half the battle. They're also maintaining a relative humidity above 80% throughout July and August.
Which is just brutal.
It is. Extreme heat combined with extreme moisture forces residential cooling systems to fight a war on two fronts. In engineering terms, we separate this battle into two different metrics.
Okay.
First, you have the sensible load. What's fascinating here is that the sensible load is just the actual measurable temperature in the room.
Right. So if it is 90 degrees inside, the sensible load is just the heat energy that needs to be removed to reach 70 degrees.
Exactly. But the second metric is the latent load. And this is the amount of moisture suspended in that air.
Which I imagine is the much heavier lift.
Oh, absolutely.
Yeah.
An air conditioner isn't just a machine that makes cold air. It is actively, physically pulling water mass out of the environment.
Wow. Okay.
In a dry climate like Denver, the latent load is very low. The machine focuses almost entirely on lowering the sensible load, the temperature. But in Oklahoma, with 80% humidity, that latent load is just massive.
I picture it like trying to mop up a flooded kitchen floor while a pipe is actively bursting overhead.
That's a great way to look at it.
If the cooling system isn't specifically engineered to pull that heavy moisture out of the air while it cools, it might lower the sensible temperature to 70 degrees, but the air still holds all that water vapor.
Yeah, and you end up with a house that feels like a damn cold cave. The machinery is just taking a beating, trying to keep up.
Right.
And, the environment gets even more complicated in the winter. The sources highlight that Oklahoma ground temperatures can drop incredibly rapidly during winter storms.
Because standard air source heat pumps work by absorbing ambient heat from the outside air and moving it indoors, right?
Exactly. So when the outside temperature plummets to near zero, there is vastly less ambient heat to absorb. That literally has the efficiency of the equipment.
How's it? Wow. Plus, you factor in the notorious Oklahoma ice storms. Ice physically coats the outdoor condenser coils.
Yeah, it acts as an insulator that traps the cold in and chokes the system's airflow. If a system hasn't been meticulously maintained to run its defrost cycles perfectly, it literally suffocates.
That's wild.
Because this extreme environment is so punishing, it pushes homeowners and contractors into a state of panic. And that exposes a massive structural flaw in how cooling systems are traditionally installed.
It leads to overcompensation,
Yes,
which
exactly.
brings up the sizing trap. And I have a confession here because I have always operated under the assumption that bigger is better.
Most people do.
Like a few years ago when my own system broke down in the middle of July, my first instinct was to ask the technician for the largest, most powerful unit my house could fit.
Right, give me the V8 engine.
Wait a second, shouldn't a bigger AC cool the house faster? I mean, isn't having extra power a good thing?
It sounds logical, right? But in the realm of thermodynamics, an oversized system is actually a disaster. It leads to a phenomenon called short cycling.
Short cycling.
Yeah. Well, we have to look at the mechanics of how moisture is actually removed from the air. Inside your ductwork, there's an evaporator coil. Cold, liquid refrigerant runs through the metal tubes of this coil, making the metal freezing cold.
So as the warm, moist return air from the house blows over that freezing metal coil, the moisture in the air condenses into liquid water and drips down a drain.
Exactly. It's the exact same physics as a cold glass of lemonade sweating on a patio table in the middle of summer.
Oh, that makes perfect sense.
But the crucial factor is time. For that condensation to occur, the air has to pass over the cold evaporator coil slowly and consistently.
Okay, so if you install an oversized, massively powerful AC unit in a moderately sized home,
It is going to blast the living space with freezing air. The sensible temperature drops incredibly fast. Within like 10 minutes, the thermostat reads 70 degrees and tells the system to shut off.
so the machine cools the air so rapidly that it doesn't have the necessary runtime to actually wring the water out of the air.
Right. It shuts off before the latent humidity can condense on the coils.
Wow. So you are just left with a cold, damp house.
Yes. And over time, that constant dampness feeds microscopic mold growth inside the dark, cool environment of your walls and ductwork.
Yikes.
And beyond the air quality issues, think about the mechanical strain. An air conditioning compressor draws the most electrical power and takes the most physical wear and tear right at startup.
Oh, it's the difference between driving a car smoothly on a highway for an hour versus driving in brutal stop-and-go traffic.
Exactly. If an oversized system is constantly blasting on for 5 minutes, shutting off, and surging back on 10 minutes later, that short cycling is just tearing the compressor apart from the inside.
So trying to buy more power actually destroys the equipment's lifespan, and it ruins your indoor air quality.
Right. This is why the sources point out that Hartzell refuses to use outdated square footage rules of thumb to size equipment.
Because relying purely on floor space completely ignores the thermal dynamics of home.
Exactly. Instead, they require a manual J load calculation for every single replacement.
And the manual J is like an engineering standard, right? It calculates the specific heat loss and heat gain of a structure.
Yeah, it's incredibly detailed. If you have a 20-foot vaulted ceiling, the square footage on the floor doesn't matter nearly as much because heat rises. That fundamentally changes the volume of air that needs to be conditioned.
And I read the calculation factors and specific insulation R values inside your walls, the infiltration rate of outside air through door gaps, and even the orientation of your windows.
Right, because a house with massive south-facing windows absorbs far more solar radiation than an identical floor plan facing north.
So performing a manual J-load calculation requires significant mathematical effort.
It does. It removes the guesswork to ensure the system runs long enough to dehumidify the air without overworking the compressor.
But even with a perfect calculation, accurately sizing a traditional air source unit is incredibly delicate. And those units are still forced to battle the 110-degree ambient air on the surface.
Right. They are still fighting the weather.
Which is why the sources introduce a method that bypasses the surface atmosphere completely. Here's where it gets really interesting. We have to look downward.
Yes. Geothermal heat pumps. They represent a fundamental shift in climate engineering.
The sources detail that just 6 to 8 feet below the surface of the lawn in central Oklahoma, the ground temperature rests at a perfectly stable 59 to 62 degrees Fahrenheit year-round.
It is entirely insulated from the chaotic surface weather.
Right. It does not matter if a 108-degree heat wave is baking the grass or a 14-degree ice storm has frozen the trees. 6 feet down, the Earth maintains a calm 60 degrees.
The Earth operates as a colossal natural battery of thermal mass. A geothermal system uses a loop of underground pipes filled with water. In the summer, instead of trying to vent the heat from your house into 100-degree ambient air, which is mechanically very difficult, The system effortlessly rejects the heat into the cool 60-degree earth.
And in the winter, it pulls that 60-degree ambient heat out of the ground and compresses it to warm the house, rather than trying to wring non-existent heat out of freezing winter air.
Right, because it is simply moving heat rather than burning fuel to create it. The sources show these geothermal heat pumps achieve an efficiency of 300 to 500%.
Wait, 300 to 500%? That's insane!
It's massive. And that level of efficiency drastically cuts down on the load placed on the local electrical grid.
Which makes sense why utility companies offer heavy incentives. The data mentions local rural electric cooperatives, like Seek Energy, offering rebates up to $2,000 per ton of installed capacity.
Yeah, the savings are huge.
A standard 3-ton system could pull in $6,000 to $8,000 in rebates, and that's before factoring in the monthly utility savings. But looking at those staggering numbers, it begs a question. If the ground is a perfect thermal battery and the efficiency is that high, what is the catch? Why isn't absolutely everyone using it?
This raises an important question. The barrier to entry involves highly complex, site-specific engineering.
Okay, how so?
Well, designing a geothermal luge requires a deep understanding of soil thermodynamics. The thermal conductivity of the earth changes drastically depending on its composition.
So a trench dug in dense, wet clay acts differently than a trench dug in dry sand.
Hugely differently.
Right.
Wet clay holds water, and water transfers heat incredibly well. If you lay a pipe in clay, it rejects heat from the house very efficiently.
Okay, and dry sand.
Dry sand acts as an insulator. If a contractor doesn't test the soil and lays a standard-sized loop in dry sand, the system will pump heat into the ground faster than the sand can dissipate it.
Oh, wow.
The ground around the pipes will literally overheat, and the entire air conditioning system will fail because it has nowhere left to dump the thermal energy.
Which perfectly explains a specific credential mentioned in the sources. The founder, Dave Hartzell, holds an IGSHPA accreditation.
Right, the International Ground Source Heat Pump Association.
Yeah, it means the underground loop isn't just a pipe in a ditch. It is mathematically mapped to extract and reject heat based on the specific geological makeup of that particular lawn.
The rigorous, math-first engineering required to calculate soil conductivity and perform manual J-load calculations creates a culture of absolute precision.
And when a business relies on empirical data rather than guesswork, that transparency naturally trickles down into their operational blueprint.
So we connect this to the bigger picture. It explains their whole customer service model.
Exactly. The internal Dave AI FAQ reveals exactly how that transparency works on the customer service side.
Yeah, the daily operations, which are managed by Dave's daughter Shelby, are structured around upfront clarity.
Like the fee structure, the AI is trained to explicitly state it's a $99 dispatch fee to get a truck to the property and a $111 diagnostic fee to find the problem.
And the document specifically notes that if the homeowner accepts the repair within 14 days, that $111 is credited toward the final bill.
It is a deliberate structural choice designed to build trust, because many contractors advertise free estimates or free service calls.
Right, but the cost of fueling a truck and paying a licensed technician's hourly wage still exists.
Obviously.
Companies that offer free dispatch simply hide those overhead costs by dramatically inflating the price of the repair parts once they find the problem.
So by decoupling the diagnostic fee from the repair cost, it removes the conflict of interest. The homeowner is paying an expert for an accurate diagnosis.
Much like paying a copay to see a medical specialist.
Yeah, you are paying for them to find the exact failing component rather than someone guessing and throwing expensive parts at the machine until it starts working again.
And we see them using sophisticated technology to make that diagnostic process even more precise. They utilize Trane connected diagnostics.
This stood out in the operational playbook to me.
That's super cool.
If a customer has compatible thermostat and opts into the program, the HVAC system physically transmits its internal telemetry to a cloud database.
Right. So if a motor starts drawing too much amperage, or a sensor detects a drop in refrigerant pressure,
It sends a fault code directly to Hartzell's before the system even completely breaks down.
the mechanical advantage there is immense. Instead of a technician arriving at a sweltering house and spending an hour testing electrical relays with a multimeter to find the issue, they arrive already knowing that a specific capacitor has failed.
It reduces return trips, ensures the technician has the correct parts stocked on the truck, and fundamentally strips the anxiety out of an emergency service call.
Absolutely.
The sources also reveal some quirky, highly specific boundaries in their operations that further illustrate this expertise. Like, The Dave AI FAQ explicitly states they refuse to service floor furnaces.
Which might seem counterintuitive, for a business to turn away work.
Right.
But it demonstrates an understanding of their own operational limits. Floor furnaces typically require technicians to work in highly confined crawl spaces, dealing with aging, potentially dangerous gas lines.
So by drawing a hard line, they protect their technicians and maintain efficiency in the services they actually specialize in.
Exactly.
They also offer a very specific preventative service, a $99 water heater maintenance flush, specifically targeted at combating Oklahoma's notorious hard water.
Yeah, the water there is full of dissolved minerals. When that hard water is heated inside a tank, the minerals precipitate out and fall to the bottom, coating the internal heating elements in a thick layer of calcified scale.
And that scale acts as an insulator, doesn't it?
It does. The heating element has to burn hotter and longer just to penetrate the mineral crust and warm the water, which drastically shortens the lifespan of the tank.
So by offering an affordable routine flush to clear out that sediment, they actively extend the life of the appliance by several years.
They pair these operational details with deep community ties, too, like mentoring at the local vocational tech schools, sponsoring the Kingfisher soccer team.
It paints a picture of how extreme transparency, backed by certifications like being a Mitsubishi Diamond dealer, creates enduring consumer trust.
They show that a locally owned business can beat out massive franchise call centers by marrying high-tech telemetry with genuine, roots-in-the-ground accountability.
It reveals how much invisible engineering goes into our daily comfort. I mean, we interact with a digital screen on the wall, expecting it to command the weather.
Right. But getting a home to 70 degrees and keeping it there safely, efficiently, and without harboring mold is a complex balancing act of latent humidity, sensible temperature, and mechanical precision.
So, what does this all mean? To bring this all together for you listening, whether you are dealing with the sweltering humidity of the American Midwest or the freezing winters of a Nordic landscape, you now know that when it comes to climate engineering, bigger is almost never better.
Yeah, absolutely.
You know that an accurate thermodynamic assessment, like a manual J calculation, is the only way to protect a home's air quality. And you know that trustworthy service is built on transparent diagnostics, not high-pressure sales pitches masked as free estimates.
Because a comfortable home is the result of working with the laws of physics, not fighting against them.
Which leaves us with one final, incredibly provocative thought to mull over. We spent time exploring the geothermal reality that right now, just 6 feet under our lawns, there is a perfectly stable, unchanging 60-degree environment.
Yeah, just sitting there.
It sits there silently, completely ignoring the blazing solar radiation or the freezing ice occurring on the surface above it. If that vast, quiet thermal battery is constantly available just a few feet down, how much of humanity's global energy grid is being completely wasted right now simply because we stubbornly choose to fight the chaotic surface air instead of working in harmony with the Earth?
It reframes the entire concept of heating and cooling. True efficiency isn't found by building a stronger shield against the weather. It is found by stepping out of the weather entirely.
Something to think about the next time you hear your AC compressor struggling outside your window. Thanks for joining us on this deep dive.